like from one IP to another IP.
Okay.
Just two nodes only know each other through uh, the same subnet. I mean, yeah.
Okay. Unicast is one-to-one. What is broadcast?
Broadcast to everyone.
Broadcast is one to
One to all. One to all.
all, or one to all is the right word. One to any is also okay, but one to all is more appropriate. Okay. Now, what is multicast?
One to many.
Mm, yeah, there is also right one to many, or any other way that you can define multicasting.
Yep, one to a different group, different
One
segment.
to group.
Group, yep.
Okay.
Segmentation, like it's a different boundary, different domain.
Many to many.
Yeah, many to many. Yeah.
Yeah, this is also multicasting. Many to many. See, we have something called PIM bidirectional. PIM bidirectional. In PIM bidirectional, it is many to many. It is one of the example of many to many multicasting. PIM bidirectional. I'll tell you one example. Let's say in a room, in a conference room, 25 people are sitting in the round table, and everyone has got a mic. Whoever speaks, they will speak in the mic. The one who is speaking is what called as the source. Out of 25, let's say one guy is speaking. So how many source you got? Only one source. How many members in the group? 25. In that, one has become source, and the others are going to be group member. 24 members are the group members who is receiving the voice through the speaker when this one guy speaks. Like this, all these 25 people can on their mic and they can talk, and others can become the receiver, which means many to many. It's not always that one guy like me speaking, you are all both quiet. That's not many to many. You see, when I ask you a question, you unmute, you speak, and I become the receiver. When Arul opens the mic and speak, we both become the receiver. When I open this mic and speak, you both become a receiver. I'm a sender, I'm a source. So what I'm trying to say here is, what we have in this classroom is what many to many. That's what called as many to many. Anyone can talk to anyone at any time. The one who generates the traffic is source. The others are receivers. Others are group members. So a group member can become a source at any point of time. A group member can become a source. Source can become a group member. That is one type of multicasting called PIM bidirectional. We'll talk about that as the last topic in this multicast chapter. So, as you said, multicasting is one to many. Multicasting is one to group. Multicasting is also many to many.
So multicasting is something like, from my understanding, like in OSPF, there's like 224.0.0.5, like is a uh, I mean, these are multicasting edits, right?
Mm. See, that's a small multicasting environment. Routing protocol is a small multicast environment. Why I'm saying small multicast environment? Because the scope of all those hello packets sent by OSPF is not more than one hop. It is not more than one hop. Can OSPF form neighbor with the 10th router? First router and 10th router, can they form neighbor without having OSPF on the middle routers?
And no, obviously not.
Not
No.
at all possible.
If it is like broadcast environment, then they can put the neighborship like with
No, I'm
10,
not
12.
talking about that. We have many routers in the middle.
Oh, oh, okay. No, it is not possible.
Not
Obviously not,
possible,
because
right? So it should be very immediate router to form neighbor. So the multicasting that works there is only on the wire that is connecting between these two routers. So the scope of that multicast is just one hop. Of course, there is a multicasting there, but the scope is only one hop. Even if you have 10 OSPF neighbor, the scope is only one hop because they are connecting through the switch. You gave that example, LAN example, segment example. You have one LAN segment, which means what? You have switch in the middle, and 10 routers are connected to the switch in the same VLAN. And when a hello packet is sent, it is sent to every 9 router in that VLAN, because the TTL of the packet will be one. The scope is one hop. All these 10 routers are in single hop, connected through one LAN in the middle. One LAN, one local area network. So, is OSPF an example for multicasting? Yes, it is. It's using 224.0.0.5. But that is for you to understand multicasting in a beginner level. Because it's a small environment, just one hop story. But the multicasting that you are going to learn, it's not just one hop story. You are trying to talk to a group which is very far away from your source, which is far from source, many hops away from source. Hope you understand the multicasting that we are trying to understand. Source is router 1, let's say. But the group members are connected to router 50, router 80, router 100, router 200. Sources are not in the middle, so sources are somewhere in remote. Sorry, the group members. Like this. You got a source, multicast source. Whatever the source sends the packet, it needs to be received by this guy, number 1, and then this guy, number 2, then this guy, number 3. You don't want anyone else. There are many other guys in the middle, many hundreds. You don't want them to receive. Your group members are spread here and there. This guy, and this guy. Only these 3 guys should receive what you send. Only these 3 computers. Whatever this computer send. the source send. Only this group member 1, group member 2, group member 3. Same group, member 1, member 2, member 3. Green group. And now, when this red source send, number 1, number 2, number 3 should receive. No others should receive. And when the same green becomes pink source, only this guy should receive. Or let's say we got another one. No one else should receive. You see? This is not that small like OSPF. OSPF is just immediate router with which it shares the update using multicast, shares the hello packet using multicast. Just one hop away. If you capture a OSPF multicast traffic, you'll see hop count TTL as only 1. But what we are learning here is something big. You got group members. See the group member. Green is somewhere. Pink is here and there scattered. Red is here and there scattered. When red source send, only the red group member should receive. When the green source send, only the green group member should receive. And the same green source can also become a pink source. When he says I'm a pink source, only the pink group member should receive. Even though the computer is same for green and pink, because the sources, computer IP address may be same, but the multicast address to which he is sending the traffic is green and pink. If it is sent to the green multicast address, the green members will receive. When it is sent to the pink multicast address, only the pink guy, this guy and this guy should receive. No others should receive. This is the bigger picture of what we are trying to learn. Multicasting. See, there is also one more called Anycast. Anyone knows what is Anycast? Anyone knows what is Anycast? Anycast. Go back. Let's say you got a network. Now here is one DNS, let's say DNS server. (10.1.1.1), your local DNS in your office. Here also you got one more DNS server, and that is also 10.1.1.1. Please understand, it's a DNS server. You can very well have something like this. In the real world, few people have got like this, I have seen. Not many. Because they don't know how Anycast works. If they know, they will go with this. Now let us say we are running OSPF in this environment. For this router, I'll call this as 2. For the router 2, which DNS is closer? 1 or 4?
1 DNS is closer.
1. So if the computer here is requesting for DNS service 10.1.1.1, the OSPF will take to this direction because this is the cheapest cost. Whereas this is, let's say, alpha computer. There is a computer beta. When this request 10.1.1.1, OSPF will say in the routing table, go this way. It will go to this way. You see, the entire office, you don't give different IP address for DNS. You give the same IP address, but the closest is responding them. Will this work? Of course it will work. It will work. What if this DNS fails? If this DNS is off, someone switched off the server. So the route will be removed from the routing table. Now router 2 will not point towards R1. Automatically OSPF will know that there is another 10.1.1.1 and it will point towards this. So this guy still has got the DNS server. Again, when this gets recovered, again it will fall back to router 1 automatically. Is this possible or not, Arul? Will this work or not? Do you see any problem in this? 100% it will work.
Sorry, sir. Give me the one more time. Sorry, I didn't
Okay.
concentrate. Can you please tell me the question again, please?
Okay. You see, we need DNS server, no, to know the domain name, IP address.
Yes. Yes.
If I have redundant DNS server, usually people will say primary DNS, secondary DNS. They will give different IP address.
Right.
See, if you are using 8.8.8.8 public DNS and then 10.1.1.1 your own local DNS, then it is okay. But if you have two local DNS, you don't need to give two different IP address. If you have two DNS like what I have shown here, one connected to router 1, another connected to router 4. I want to use the closest DNS. So instead of giving two different IP address in this DNS, give the same network, same IP address for the segment. This segment is also 10.1.1.24. This segment also you give 10.1.1.24. So when you run a routing protocol, the closest will be picked. Router 2 will say this is the best, closest to
Correct.
reach. Router 3 will say this is the best. So when beta tries to reach DNS, he will use the DNS that is connected to 4. When alpha tries the DNS, he will be directed by the OSPF, he will be directed by the routing protocol to reach the DNS which is in router 1. They go to the closest. That is the meaning of any cast. 1 to the closest. Right, so we learned about unicast, multicast, and anycast. And anycast is nothing but 1 to the closest. All right, so our focus is on multicast. Let's begin multicasting. Multicast is very important for a certain scenario, not for all scenarios. So we are going to see where to use unicast, where to use multicast, where to use broadcast, or we are going to see how multicast is so important. Why should I use multicasting? Why should not broadcast? Those things we are going to see. As you said, if you are talking to one destination, we need unicast. We need to do unicast because it's one particular destination to which you want to talk. To talk, you already got IP address. You don't need any additional service. You don't need any additional protocol. Unicast is there in IP routing by default. You just put the IP address and you telnet. You are able to do unicast. Telnet is an unicast. SSH is an unicast. Now, if I want to send something to everyone, regardless of who they are, then I'll use multicast. This is the global multicast address. Sorry, I'll use broadcast. I'm sorry. I'll use broadcast if I want to send to everyone, regardless of who they are. I'll send to 255.255.255.255. This is a broadcast address. Anything destined to this address can be opened by anyone who receives it. Please understand. When I send a packet to this address, anyone can open the packet that is delivered to this address. Right? Anyone can receive the open the packet. See, everyone will receive the packet, but who can open it? It depends on the destination
Anyone.
address. If the destination address is 255.255.255.255, anyone can open it. Anyone can open it. That is why we see in RIP version 1, when you send an update, even printer can open it. Printer in the network can open it. Scanner in the network can open it. But they don't understand RIP, they will drop it. After opening, they will drop it. Okay. But when you use multicast address, like RIP version 2, not all routers can open it, not printers can open it because they don't belong to the group. Only the RIP version 2 enabled router belong to the group. Only RIP version 2 enabled router can open the packet. Others cannot open the packet because the destination says it is only for 224.0.0.9 members. In RIP
So I
version
have
2.
one question here. In the group, everyone can open the packet, right? In the group.
Yeah, correct. You
In the
see,
group, everyone. Okay.
if you have 10 routers and only 5 routers are enabled with version 2 RIP.
Mhm.
Only 5 routers are enabled with version 2 RIP. Now, when RIP sends the update, all 10 will be receiving the packet, no doubt. All 10 will receive
Yeah.
the packet. After receiving, they read the layer 2 and layer 3 destination address. In that destination address, they see it is for a particular group called 224.0.0.9. So those RIP version 1 router, they see the destination address is 224.0.0.9. Will they accept the packet or not?
No.
They will accept.
Sorry. I mean on that. I mean
No, no,
on that
no.
group, like
Actually, my question is
yeah.
tricky. What you answered is correct based on what I was talking, but at the same time, it is wrong also. Repeating again the question. I'm repeating again the question. Arul, are you there?
Yes, sir.
Okay. I want both of you to answer this question. It is a tricky question I'm asking. So to make it more clear, I'm going to ask two questions. Okay. Now, there are 10 routers and 5 printers in a LAN. Okay. 10 routers and 5 printers in a LAN. And 5 routers are running RIP version 2. The other 5 are version 1. Okay. Now, version 1 router is sending an update. My question is, will all the other devices, printer, version 2 RIP router, receive the update, or any particular device receives the update?
For the version 1.
I'm sending version 1 update.
Yeah.
And
For the version 1 update, they will receive all the
Version 2 will
routers.
not receive.
wait, what
Version 1 update.
Rahman says is an interesting answer. I want to hear more from Rahman. Can you go please a little bit detail?
in version 1 RIP, basically, or is it called broadcast concept like 255.255
Mm-hmm.
dot 250 everything.
Mm-hmm.
So um, okay, no, in the question there's a tricky thing. Like you already mentioned some routers in group, uh, in different group.
Five routers are in
I
version
mean,
2, 5 routers are in version 1, and there are 5
okay,
printers.
the okay, the version 2 routers, they will not receive the packet from the uh, uh,
Version 1.
from the
That is
version 1.
what Arul was saying. You are also agreeing with that. Is that true, Mr. Raman? Is that you are saying? You agree with Mr. Arul?
All the printer, all the
Mm-hmm.
printer and all the version 1 router will receive packet from the from the version 1.
Mm.
Yep.
Okay. But the answer is wrong. I'll ask you one question. Try to answer. Okay? Are you ready?
Yeah.
Fine.
Yeah.
There are 10 people and 5 monkeys. 10 people and 5 monkeys. And I'm saying, give this fruit to all. Give this fruit to all. See, there are 5 monkeys. I don't deny that there are 5 monkeys. Version 2 routers. Version 2 routers. 5 monkeys. I have 5 monkeys. Among 15, 5 are monkeys. 5 are version 2 routers who don't belong to human group. But what did I say when I give the fruit? Give to all.
Give to all.
When you say 255, 255, 255, 255, do you think that multicast status 225, sorry, 224.009 is not included in that? All includes all,
Okay.
isn't it? All includes all.
Yeah.
All includes multicast group members, unicast members, everyone.
Yep.
So the packet that was sent by version 1 router will go even to version 2 router and also to the printer. But version 2 router, after receiving it, it will open also, because it is said to everyone. It will open. After that, the RIP algorithm will say, hey, no, 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 no. We don't really process this version 1. It's an illegal version for us because it is coming without any subnet mask. We are not going to accept this. So that is RIP's decision, but routing decision, it accepts it. It processes it. It is processing it. That is very important. It is processing it. After processing, RIP is saying it is an illegal version. I'm not going to take it. Okay, now I'm going to reverse the question. Version 2 router is sending an update. Version 2 router is sending an update. What it means that I'm saying, give this fruit only to monkeys. There are 5 monkeys among 15, 10 are human beings, 5 are monkeys. There are 5 version 2 routers, 5 version 2 routers. And I'm sending update from version 2 router. Will this update go to everyone or okay,
No.
to whom it will go?
It will go only to the group
It will
2.
go only to version, it will go to everyone, but only the group 2 member can
Oh,
open it because the destination says hey, this is for monkeys. And monkeys will say, hey, it's me, it's mine. I'll grab it. Everyone will see the fruit, but cannot open it because the human being says, it is written only for monkeys. So let me not touch it. They see it, but they don't open it. When they receive the packet, they see the destination address, and version 1 router says, oh, it's not for me because it is very precisely sent to 224.0.0.
Fine.
So version 2 router receives it. Version 2 router receives when version 2 send the update. The printers cannot open it. The printers cannot open it.
No, printers cannot.
Anyway, coming back to the story, uh, that is one small example of multicasting. That's one small example of multicasting. Now, actual multicasting we are going to see now. Now, why should I use multicasting? Why can't I use broadcast? You see, if I send broadcast, everyone will receive. In that everyone, monkeys are there, group members are there. Why can't I send to a broadcast? Answer is, if you send to a broadcast, everyone will think that it's my food, my food. After opening, the human beings understand, it's not my food, it's monkey's food, and they close it. They're very hungry. They thought, my food is coming, because on the top it is written broadcast. Everyone opens the packet very eagerly to eat, and later they see inside it's monkey food. Oh, let's close this and keep it. They drop it. So you cannot replace multicast with broadcast, because if you do that, we are wasting the bandwidth, not only bandwidth, the process. They all unnecessarily open the packet thinking that it is for them. When you send to a broadcast address, they open the packet thinking that it's for them, and after opening, they find that it's not for them. It's a waste of process. Instead, if you will assign a group ID called multicast IP address, and when you send it to a group address, a packet, the receiver will check whether I belong to the group before opening it. The receiver will check whether I belong to this group before opening it. If yes, only then it will open it. So it reduces the wastage of process. Multicasting is good. Now, can I do unicasting instead of multicast? See, there are 10 people in the group. If I send to a multicast address, all 10 are receiving. Among 100 people in the class, 10 people, 100 people in a school, 10 people belong to 5th standard. Out of 100 people in the school, 10 people belong to 5th standard. If I send a packet saying this is for 5th standard, it goes only to the 5th standard. The other 90 people, they don't take it. When I do broadcast, all 100 opens it and 90 people rejects it after reading the packet. That's a waste of processor. Now my question is, can I do unicast to this 10 people instead of multicast? If yes, why? If no, why?
Unicast, it's
Yeah.
1-to-1.
Out of 100 people, I'm sending to 10 people. Can I use unicast instead of multicast? If yes, why? If no, why?
No, it is not possible.
Why?
Yeah.
Why it is not possible? See, instead of sending,
Okay, if I say the like unicast concept, it
You will not
means
send any of the IP address.
packet will come one single packet, one single packet go to the one destination is
Okay.
called the unicast concept. In here, one single packet coming and the same time the same packet will go everywhere. This is a kind of unicast concept. This is a, I mean, because the packet is transmitting like in a single time to everyone. This is kind of
Okay.
unicast
See,
concept.
I appreciate. I understand that you know the answer, but let me put it in my words. When I do unicast instead of
Okay.
multicast, I need to take one packet. The same packet I need to duplicate 10 times because I need to do unicast. When you say unicast, it is 10 different IP address, isn't it? 10 different IP address. That is what unicast, right? I want to send a packet to 10 people, which means I need to send
Yes.
to 10 different address, which means I need to have 10 separate packets. 10 separate packets. Same packet, you have to duplicate 10 times and put 10 different addresses as the destination. What will be the result? More process utilization, more bandwidth utilization, isn't it? But when I do multicasting, as you said,
Yep.
I'm sending just one packet with a multicast address, which identifies 10 device. That one address is identifying 10 device in just one go. So I no need to duplicate the packet. I just put that multicast address and then I deliver the packet to all 10 simultaneously. So bandwidth utilization is also not 10 times more. Processing also not much utilized. Did you understand now what I'm saying? See, every computer has got an IP
Yes.
address, no doubt. But on top of that, we give another IP address called multicast IP. And if among 100, 10 devices have got that particular multicast ID, they form a group. See, everyone has got their own name. Ramesh, Suresh, Mohammed, Rahman, Abdul, Irfan, Aisha, Tasmiya, Tansira, um, Ram, Raj, Joan, Bob. In the school, 100 people are there. That is like an IP address. But they also got another IP. 10th standard children, 5th standard children. That is what multicast address. When you say 10th standard, inside you see Sam. Inside you see Joy. Inside you see Diallo. Right? So you see many people inside when you say 10th standard. So they got two identity. Hey, who are you, man? That guy will say, I am 10th standard student. Is that a real ID? Yes, of course it's an ID because he is in 10th standard. But he also got a unique ID which is used for unicast, that is Sam. So if you send the packet to Sam, it goes only to Sam in 10th standard. But when you send the packet to 10th standard, just single packet goes to every single member in the 10th standard, including Sam. So which is going to consume more bandwidth. Unicast will consume more bandwidth if you are talking something common for many people. Don't use unicast, use multicast. If you're going to talk to many, not all, many, means you're trying to talk to a group. If you are trying to talk to a group, don't use unicast because it's going to increase the bandwidth because you need to duplicate the packet to as many that you are going to send and put their IP address. Instead of doing that, instead of saying the 10th standard, in 10th standard you have Sam, Joy, Rom, instead of saying this is to Joy, this is to Sam, this is to Rom, instead of saying like that, say simply 10th standard. It goes to all of them. Single packet. Now, I just explained you the advantage of multicasting, advantage of using multicasting over unicast and broadcast. Is that well understood?
Yeah, that's fine.
Now,
That's all right. Yeah. So this is something like very much like IPv6 multicasting group. Very similar
IPv6
concept,
everywhere
isn't
it
it?
uses multicasting. Now, the next thing is for multicasting, we understood that there is a sender and there is a receiver. Receiver is a group. Now, let's take simple example. Order 1, order 2, order 3, order 4. Now, let us say there is a member called blue 1 and a member called blue 2. Now, here there is one person who is the sender of blue traffic. He is a source. Whenever this blue source send a traffic, that needs to go only to that B1 and B2, not to anyone else anywhere in this topology. I have not drawn. There may be 100 computers here and there. There may be many members. When blue source sends the traffic, I want it to be received only by B1 and B2, which is in R1 and R4 and R5. Likewise, if green source is sent somewhere, when they send, it only should be sent to R3, LAN and R6 because there are two green members. From somewhere, if some red source send a packet, it should go only to R2 and R3 members because you got red there. For this, first of all, this red, blue, green need to be defined in networking. For me and you to understand, I'm using colors. Whereas in networking, we use address, which is what called as multicast address. For example, for blue, instead of blue, I'm using the word blue. Instead of that, 224, like 10, 10, 10. So we got a multicast range like 224 to 239. Any address starts with in between 224 to 239 is a multicast range address. So you should not use those reserved multicast address. For example, RIP version 2, 224.0.0.9. Don't use that. So try to avoid that 00 here because those ranges are already reserved. Or in the lab environment, try to start with 239 instead of 224. So for blue, what I'm going to do is I'm going to give a multicast address 239.1.1.1. So the source member will be sending the packet to this address. His original IP address may be 10 on this is his original address, original source. And the destination to which he is generating the traffic is 239.1.1.1. When this packet is sent, I want only these two members, these blue members, to receive, which means, see, he has got already an IP address. On top of that, I am going to give him a group ID. The group ID is what? 239111. Here also 239111. So that when a packet is sent, it will be received by both B1 and B2. Did you understand how multicast address is used? On top of your own unicast address, an additional ID is given which is going to identify you in a group. Is it clear? Is it clear? Now, to
Yeah,
join
sir.
this group, you need a protocol. To add this, that is what it means, joining the group. To add this additional identity to your device, you need a protocol called Internet Group Management Protocol, IGMP. Using IGMP, you're going to say, I belong to 239.1.1.1. Using IGMP. IGMP is the protocol that we use to log into a group, right? So it will help only to join the group, nothing more than that. See, there is a sender, there is a group, but in between you have a big network, isn't it? In between there are wires, there are routers. See, router 4 knows I have a member who has joined this 239.1.1.1 with the help of the protocol IGMP. Likewise, router 5 knows I have a group member called 239.1.1.1. But how will router 2 and router 3 knows that there is some group member? You understand what I'm asking? Do we
Router 2 and
do
router
we have
3.
any member connected in router 2 and router 3 who belong to 239.1.1.1? No, we don't have anyone. See, when you use
No.
IGMP, R5 will know that you have a member. R4 will know that you have a member. But sender is where? Sender is R1. When he sends, there are other many middle router who do not know that there is someone called 239.1.1.1 group. And how will this communication happen? Please understand. I repeat. R1 says, I'm sending the packet to this fellow. R4 and R5 knows that that fellow is here. But how router 2 and 3 knows that fellow is in that direction? I need to forward this. No idea, right? IGMP? Ah, you have
Using a
another
protocol.
protocol
Using a protocol.
called PIM, Protocol Independent Multicasting. That is what I was about to bring it to you. So the scope of IGMP is only here. Only here. So when this guy send the packet, R1 also should know in which direction I have to forward. Where the group members are should be known to R1. R2 also should know. R3 also should know. Only then the packet can go to R4 and R5. If the middle routers do not know where they are, where the members are located, the group members are located, this multicasting communication cannot be successful. I'm trying to explain you that there is a protocol and the protocol need to be enabled on every router in the path. Right? It needs to be enabled on every router in the path. That is what PIM, protocol independent multicasting. So this is like a kind of glue between the source and the group member. With this PIM only, the control plane gets built. What is control plane? The plane which is going to direct the traffic, explains the flow, explains in which direction the group members are sitting and where the packet need to be pushed. When the multicast packet comes to destination 239.111, if it needs to go there, R2 will know where to forward it. Should I forward it to R4? Should I forward to R3? From where it learns? It learns through this protocol PIM. With the help of PIM, protocol independent multicasting, a multicast control plane, if I need to put it in a simple term, a routing table for multicasting is built. A routing table for multicasting is built on every router. When you enable multicasting, you must enable PIM on every router in the path. Every router in the path, you need to enable PIM. Only then the path to reach the group member will be updated to the router. You understand the use of IGMP? Did you understand the use of PIM? So IGMP is only just to
Yes, yes.
join the group.
Join the group.
The
Yes.
PIM is the one which is distributing the location of group member as well as the source. I repeat, PIM is the protocol that distributes the information about the source and the group member to all the routers in the topology, so that when a traffic from a source comes, it can direct the packet to the correct destination where the group members are located. What you have learned is the building block of multicasting. Multicasting control plane is called mroute table. This is the command we type: show IP mroute. This will show you the routing table of multicasting. Not simple routing table. Simple routing table you used to type show IP route. This is show IP mroute. So what I'm going to show now is a demo. This is an introductory demo
Sir,
for multicasting. Yes, question.
so that R1, for this example, we use 239.1.1.1.
No. That is not the
Okay.
source.
So in the
That is
same
not the
R1,
source.
we have the another sources.
10.1.1.1 is the source. Destination to which the packet is sent is 239.1.1.1.
10.1.1. Okay. So for the
I use
blue network,
239,
if it is a
2.2.2.
red network, we can use the another
Yeah, same
dot.
PC can
Okay.
be the source
In the same
for
router.
red also. 239, 2.2.2. Yeah.
Also, we can use another
Yes.
multicast address. Okay. Okay.
Now I'm going to simulate this thing in the lab environment, and this will be the introduction
Okay.
demo.
Okay.
We are going to go much more deeper in coming days. This is just what you learned so far. You're going to see.
Okay.
Let me see whether I have any topology. No, let me build a new topology. M cast lab1. I'm going to take 1, 2. Now for testing we have taken this. I need to take more out. Multicasting unit. I don't know. I want to use any application. See, for multicasting in the real world, we use some applications. But I'm using the router itself so that I don't need an application to test. Okay, 6 and 7 are going to be the group member of one particular multicast address. Now let's put the IP addresses. And also we'll run OSPF. I'm going to take some loopback for testing. These loopbacks are going to be the destination, the group members. The multicast address that I'm going to use is 239.40.40.40. And now the group members are R6 and R8. No other group members. Whenever I send any traffic from anywhere to 239.40.40.40, only router 8 and router 6 should receive it. No other should receive it. We are going to test this. Okay, so I'm going to R1, notepad. First, let me create a template for the routers, and then I'll quickly finish this. Okay. Now next is for router 2. I'll come later. I'll go to router 6. Router 6 F00 will be 1046. Don't ignore this, keep following because you're going to also add another multicast address to the loopback using IGMP later. Alright, you need to make sure what I am giving already in the routers. Don't ignore thinking that I'm just giving IP address. Now this router 8. 1038. Alright, now let us move on to router 3's configuration. So we got IP address for F01, which will be 3 here. And then
3.
we will have,
3.
instead of this, we'll have F00 23. That's all on router 3. We don't need loopback. I don't want to do it now, later maybe tomorrow. Today I don't want any loopbacks on R3. So we got R8, R3, R7, R6. Now let's move to R4 and R5. R4 F00 will be 24.4. F01 will be 46.4. This is R4. Now R5, let's do R5 is 25, 5, 57, 5. On F00 it's going to be 12. Dot 2. F0/1 will be 23.2. We got two more interfaces. F1/0, which is 24. F1/1, which is 25.
0/1.
Put it on router 2. Okay. I believe that I have configured all the routers. If I will be able to ping from R1 to R6, 7, and 8, then all are good. Ping 8888. Good. Ping 66666. Ping. Sorry. We got reachability, which means our OSP is good. Here we start multicasting. So we want only two members to be the group members. Who are they? Who are those two that needs to be the member of the group? Please respond. No, it's already there in the screen.
It is number
Router
8,
8 and router
number
6.
8,
For
and the
this,
number
what
6.
we have to do? For that, go to router 6 first. And I'm going under the loopback. Assume that loopback interface on router 6 is a computer connected to the router. I'm going to that computer now. I'm inside the computer interface loopback 0. I'm saying IP IGMP join group. What is the group number? 239.40.40.40. All right. So see, you need to know that we already have an IP address on loopback interface. On top of that, we are adding that interface to a group. So this interface I've got how many IP addresses now? 2 IP addresses. Even your computer, no? Your computer will have an IP address and you will have some software. You'll have some software using which we'll join the group. That software will be running on IGMP. Of course.
So in real world, we have to install that
You're
software
not
on
going to
IGN.
install that software. You'll be installing some application. That application will have that software inside, and that software will have that multicast address. You will not even define the multicast address. When you buy some applications, they come inbuilt with that. For example, you buy some intra chat within an organization. You want to do chatting. You install a software. Automatically, the software will go and add the multicast address for the chat application, which is predefined by the vendor. In my case, it is 239.40.40.40. So all those things will be taken care. Now let us not go into those details now. Maybe later. Let us focus on this thing. We want R6 and R8 to be the group member. Who will receive the packet if I send it to 239.40.40.40? Okay, I have joined the group here. Now let me also do the same thing on R8. IP IGMP join group 238. Sorry, what number? 239. 239.40.40.40. Now what is next? All the routers in the path should run PIM. So let me start from router 8. Interface range loopback 0 and fast Ethernet 0/0. IP IG sorry IP PIM. IP PIM. I said I need to enable PIM on all the router. And the PIM has got two modes. I'm just going to enable dense mode. We'll talk about this dense mode later and sparse mode and dense mode later. Okay, when I say this, it says, hey, your router is not enabled with this service. Yeah, of course, yes. This is the first command you should have given on every router. So I'm going to put that command first. Globally, you put the command. Okay, let us maintain a notepad. Enable config team. Put this command. Interface range loopback 0, f 0/0, and this multicast address IP pim dense mode. End write to memory. All right, I'm going to paste one more time on R8 and then R7. I'm going from down
R6.
and then R6. It should be enabled on every router in the path. Even though R7 is not there, I'm just enabling for future, for tomorrow. Okay, so R7 is there, R6. Now let's go to R5. On R5, I have one more interface, -1. This is router 5. And then R4 also same. And then R2, sorry, R3, no? R3. R3 also same interfaces. Okay, and R2 and R1 I'm going to do manually. On R1, I'll say, hey, what is this? R1. IP multicast routing. Interface range loopback 0, f 0/0. IP IG IP pim dense mode. Likewise, I'll go to router 2 and enable IP multicast routing. Interface range f 0/0 -1, f 1/0 -1.
0/1, only one interface.
Correct. IP pim dense mode. So I'm expecting 4 pim neighbors. It has come. Show IP pim neighbor. You see, I should see 4 neighbor, router 1, router 3, router 4, and router 5. Excellent. Now you're going to see the final result. I'll go and generate traffic. You can generate from anywhere, not only from R1, you can generate from anywhere. I'm going to generate from R1. I'm going to send a traffic to the multicast address.
So why it shows only the four neighbors from R2? So why it shows only the
Only
four
4
neighbors
routers are
from
connected
R2?
directly, isn't it?
Okay. Is the neighbor only. Okay.
Okay.
Is the
Now
neighbor
I'm
only.
generating a
The
multicast traffic.
neighbors.
Listen here. We are not using any application, multicast application. So I'm using PIM to generate some traffic to this address. What address? 239.40.40.40. If only R6 and R8 is receiving, then they only should respond me, reply me. No other should reply me. That's the proof that multicast is working. Shall we check it? Are you ready? Let's do it. You see.
Yes.
Look at this. Only 6 and 8 is replying. No one else have replied. No one else have replied. Right? We'll stop here.